Unit 5.10, we do practice. For the first part of this question, they ask us to draw a reaction energy profile of a reaction on the graph below given the following information. So something to keep in mind before we start is that our transition states are going to be our peaks and our intermediates are going to be our low points, kind of our troughs. So when we draw this, including our three different transition states and our two different intermediates and our reactants and products, we get a graph that looks something like this. So part A asks, how many steps are in this proposed mechanism? And to determine that, we can just count our peaks or our number of transition states. And so for this one, we have 1, 2, 3 transition states. So this is a 3-step mechanism. For part B, they ask us, is the reaction overall exothermic or endothermic? And for that, we have to compare the energy of our reactants to our products. And since the energy of our reactants is higher than that of our products, we know that energy was released as we transitioned from reactants to products. So overall, this reaction is going to be exothermic. Finally, part C asks us, which is the rate determining step? And often the easiest way to do this is look at the graph and determine which step has the highest activation energy. So when you're doing this, make sure you're going from trough to crest. So for the first one, we'd go from reactants to our transition state 1. But then for the second step, we are going to go from our intermediate 1 to our transition state 2. And then for our third, from intermediate 2 to transition state 3. We're not going from reactants to transition state for each step, only for the very first step. So since it's a little bit difficult to eyeball this graph and get a sense of our activation energies, we can actually use our table and actually calculate the activation energies. So if we plop in our original table that we created this graph from, and we do a little subtraction, we can get our activation energies for each of the 3 mechanisms involved in this reaction. So now that we can see our activation energies for each step a little more clearly, we're now going to look for the highest activation energy because that is going to be our rate determining step. So when we look, we notice that this right here, our activation energy for our second step has an activation energy of 20 kilojoules per mole. So that means step 2 is going to be our rate determining step for this reaction.